Hello everyone. Today I'm going to talk about HAMMR, Human-Aligned Multi-Agent Manipulation Through Reasoning, a framework for language-guided robotic manipulation. Let's get started. Recent advances in LLMs have enabled impressive robotic manipulation systems. Systems like say CAN, code as policies, and MALMM can interpret natural language commands and autonomously execute complex tasks. However, these systems share a critical limitation. They prioritize execution efficiency over human understanding. Users cannot see what the robot plans to do before it acts. There's no way to validate safety, adjust parameters, or intervene when something doesn't look right. This opacity creates a fundamental barrier. How can you trust a system you can't understand? This isn't just a practical concern. It's also a regulatory one too. The EU AI Act now mandates that high-risk AI systems, including robotics, must provide interpretable outputs. HAMMR addresses these challenges through two key innovations. First, explainability with mandatory human approval. The system generates complete plans with step-by-step justifications, explaining why each action is necessary. It assesses risk and presents adjustable parameters. You review, adjust if needed, and approve before execution begins. Second, only after you explicitly approve the plan does autonomous execution begin. Specialized agents for sensing, perception, and motion work together seamlessly to complete the task. Together, these innovations deliver transparent, controllable, and trustworthy robotic manipulation. Let's see how HAMMR works in practice. The workflow has two distinct phases. In Phase 1, planning, the user gives a natural language command, like, pick up the red cube. The planner agent immediately generates a human-understandable plan with step-by-step justifications and presents it to the user. The user can review the plan, adjust parameters if needed, and then explicitly approve it. This creates a clear decision point before any physical action occurs. Once approved, Phase 2, execution, begins autonomously. The sensing agent loads the task and captures multimodal data, RGB images, depth maps, and point clouds and sends these multimodal paths to perception agent along with the prompt. Then perception agent uses vision language grounding to detect objects and compute their 3D positions. Finally, the motion agent executes the approved sequence, opening the gripper, approaching the cube, grasping it, and moving it to the target position. Upon completion of the request, a task report is sent to the user. Let's start with the demo for pick and lift task. User sends pick up the red cube request to the system. Upon receiving the request, planning agent presents a detailed plan with risk level, step-by-step justification along with adjustable parameters to the user. User approves the plan, which triggers the sequential sensing perception motion agent pipeline. HAMMR leverages multimodal perception for rich environmental understanding. GroundingDINO enables open vocabulary object detection, no pre-training on specific objects required. Our framework uses MCP to decouple LLM-based reasoning from low-level robot implementation details. Agents operate through human-readable commands such as move to position and control gripper, rather than directly handling joint angles or inverse kinematics. Finally, task completion report is presented to user. We evaluated HAMMR on 5 RLBench manipulation tasks, ranging from simple reaching to complex multi-object stacking. Across 75 episodes, HAMMR demonstrates reliable performance with 89% task success rate while maintaining complete transparency.